Hi guys, welcome to 4-2 Triangle Congruence by SSS and SAS, also known as side angle side. Let's jump right into this thing. Okay. Postulate 4.1 states, well, 4.1 is the side. It's known as the SSS postulate. Anytime you see an S, it stands for side, A stands for angle. Okay? This says if the sides of one triangle are congruent to the sides of another triangle, then the two triangles are congruent. So for example, if AB is congruent to DE and BC is congruent to EF and AC is congruent to DF, then triangle ABC is congruent to triangle, well no, we got match these up. A matches up with D, B matches up with E, F. Okay, now I could also say angle A is congruent to D, B to E, and C to F, but we'll save that for a different day. Okay, next slide. Alright guys, let's do a proof. So according to this, we have LM congruent to NP, and we have LP is congruent to NM, and we want to prove that LMN is congruent to NPL. Okay, so our statements, our reasons, make our good old proof box. Okay, so we always start off with our given, right? And that is because given. Okay, next step. Well, considering where it says using side at the top, we need to get this third side congruent. Well, how can we say that this third side is congruent? Can you say LN is congruent to LN? Now here you go. Do you guys remember what property that was? That's your good old reflexive property. Okay. Now you have property of congruence. Okay. Now, I know I have one side congruent, two sides congruent, three sides congruent. So I can state triangle LMN is congruent to triangle NPL by the side theorem. And I'm done! Ta-da! No train explosions. Okay. Next slide. Okay, we're halfway through actually, guys. The other postulate we need to learn is side angle side. What that states is if two sides are congruent and the angle in between, then the two triangles are congruent. So make sure you draw this. Now your side angle side has to be in that order, okay? That means you have a side which sandwiches in this angle, then you have your other side. It's like an angle sandwich with sides to your bread. Okay. Don't use, because if you have a triangle and you have two sides in an angle, you have side angle theorem. And don't make a side angle out of you or me, okay? How do you guys think about that one? Has to be in between side angle side. I'll let you guys ponder that for a second. Here we go. So according to this, what other information do we need to prove these two triangles are congruent? Well, your LEB, LEB, and your BNL. Okay. Well, I have an angle, right? I know angle BLE is congruent to angle LBN. So I have one angle. I'm going to need to get two sides. What do you know about this guy though right here? Don't we know LB is congruent to LB? Yeah, by reflexive. Careful, that one's going to come up a lot. So what else do we need? Well, could we say LN is congruent to EB? No, because you don't know the angle. What you need, we need NB to be congruent to, where do I go? NB, so I'm going to need to go EL. Because if you look at the picture, if I mark these, then I have side, angle, side. Okay, SAS. SAS. When I follow letters, I have SAS, and that is one of our congruence theorems. So if I had this, they would be congruent by side, angle, side. Alright, one more slide. Okay, last one. Name the postulate you'd use to prove these triangles congruent. For number 3, well, I have a side, I have another side, but I don't have this third side, so I can't use SSS. But what do I know about these two angles? Are they going to be congruent? Yeah, they're going to be congruent by vertical angles, right? So I have a side, an angle, and a side. So it's side, angle, side. Okay. Now on this guy, I have a side, I have a side, I have a side, I have a side. But I don't know any angles, and I can't use any theorems to prove the other ones. But look at this guy. Could I say it's congruent to itself by reflexive? Yes. That's by reflexive. You can say it's congruent to itself. So I have a side, side, side. So that one is by side, side, side. This one's by SAS. Okay? Guys, that's all there is to it. I hope you enjoyed. See ya.